Okay, guys, this is another example for the ANOVA test using the F test. Okay, so in this example, we are looking at the delivery times for four different food services companies. So the first one being DoorDash, Uber Eats, Skip the Dishes, and Foodora. Okay, so let's assume that you believe that Uber Eats and DoorDash may be faster than the other ones, and you just want to try and figure out if the delivery times for these four groups are similar or dissimilar. So you do collect a sample of 10 observations from each of these services, and you want to try and figure out if the means are similar or if the means are dissimilar, right? So we will be looking at this sort of example. The means are similar for these four service companies, and the alternate hypothesis being that they are not equal. Okay, so this is the hypothesis, and we will be testing this using Excel this time instead of computing every value by hand. So the first example, the first way of computation, I did compute this initially. So remember that the F statistic, in some sense, the F statistic is going to be the mean square of the treatments divided by the mean square of the error. Okay, so the mean square of the treatments is the estimate of the population variance between different samples, and the second one is the estimation of the population variance based on within each sample variance, each sample deviations, and so on. So the first one, we will be looking at the averages. So you have the average to compute it. For DoorDash, you just compute the means. And once you have all the means, you could compute the total mean of all the samples. And this is known as your grand total. It's just the same value, and I just put them. And the second one is the square differences. Okay, so the differences between each of them. And since there are 10 observations in each sample, this is going to be the square difference multiplied by 10. And once you have the square differences multiplied by 10, and you sum them all up, that is going to be your sum of squares for the treatments. So the sum of squares for the treatments from your textbook, I think it's shown as, okay, go back. The sum of squares of the treatment will be each individual value minus the overall grand total, and it'll be the sum of square those deviations, and it'll be the sum of squares of that, and that will be your sum of squares of the treatment, which in our scenario is 24.85. The second thing which we need to find out is the sum of squares of errors in some sense, and it is within group variation in some sense. So the within group variation is the easy to find out because you can just use the variance function. We'll just be using the population variance formula, the scenario. So find out the variance function of, and select these 10 observations in Excel, and you have the variances for each of these groups. And the sum of the squares of the errors is going to be sum of all these values. But since there are 10 observations in each group, we multiply them by 10. Ideally, you'll multiply each value by 10 and then add them all together. But since we're not doing that, we'll be using since they are all the same 10 observations for each sample, which is the same, so we can just multiply them by 10 in a common scenario. And so once you compute the sum of squares of treatments and sum of squares of errors, so these two, when you add them up together, you get the total variance. And the total variance can be found out by just using the variance formula for all 40 observations, and you multiply them by 40. So this is not exactly the total variance. This is the total variation in terms of sum of squares. Okay. For variance, you actually divide by 40, but since the variance is already divided by 40, we are multiplying by 40 again, so that it's just the sum of squares instead of being the variance. Let me expand this. And once you find that, you know the degrees of freedom for the numerator is k minus 1. And the degrees of freedom for the denominator is n minus k, which is 40 observations minus 4 groups, which is 36. And for k minus 1 is 4 groups minus 1, which is 3 groups. And then you find out the degrees of freedom. Okay, so then you find that the mean square of treatment is going to be each of the sum of squares of treatment divided by the numerator degree of freedom, and the sum of squares of the error divided by the denominator's degree of freedom. And once you have that, f value, the f statistic, is just the MST divided by MSE, which is 1.17751 in our scenario. So how do we know if they are similar to each other or not? Well, let's go and compare if this f statistic is greater than the critical value. So let's find out the critical value. And let's see if this f statistic is greater than the critical value. So the critical value, we look at the degrees of freedom. Let's go back to our table. Let's look at the 5% level of significance. At the 5% level of significance, the new degrees of freedom in the numerator are 3. Degrees of freedom in the denominator is 36. Well, let's try and go somewhat close to 30 or 40. Even if you just look at 30, even if you look at 40, it's around 2.84. And the 30 is 2.92. So let's say the degrees of freedom is around 2.9 or 2.89. So that's our best guess of f statistic. The critical value of f is 2.89, and our f statistic is not greater than the critical value, so we do not reject H0. Okay, so this is how you could compute the f statistic by using the variation and all these formulas. Another much simpler method is using Excel, where you go to your data tab, and if you have your data analysis toolpack installed, you could click on your data analysis, click on this Anova single factor, and actually, select all these observations. These are the input ranges, labels in the row. You could select all these observations. Alpha is given as 0.05, and then you select where you want your output observation. But I already computed these results for this, and these results are over here. So the variance for each of these things are given here. Averages are given to you, and they are the same as over here. The variance, these are used as population variances. They're a little bit higher than the variation within group. That's the only difference. So these are sample variances, sorry. So once we find that the sum of squares between groups, expand this, the sum of squares between groups is known as sum of squares for the treatment, is found out over here. The sum of squares within groups, within each group, or the sum of squares for error is 253. These are the same values which we found out over here. The degrees of freedom are given to you, the mean squares are given to you, and the f statistic is computed. Okay, and the critical value of f statistic is at 2.866. We made it as 2.89. That is also computed via Excel automatically. So as we can see, the f value is not greater than the critical value, and so here we reject it. In fact, the probability of type 1 error is actually given at 33.18%, where the maximum level, which at alpha as 0.05, is 5%, right? So there's a 33% chance that this is not true, and that's a very, very high number. So you cannot conclude that DoorDash or Uber Eats or Skip the Dishes and Foodora, they all have different means. Even though you could see that DoorDash and Uber Eats have slightly lower means than Skip the Dishes and Foodora, because of their such high variation within those observations, you cannot be confident in saying that these have different means. So therefore, you conclude that the delivery times of all 4 of these food services remain the same. So now let's look at another example. So what I ended up doing here in this example is pretty much have the same observations over here. Same observations, but I added more observations to DoorDash, Uber Eats, Skip the Dishes, and Foodora. So maybe one of the reasons you get such a low f-test is because there's a lot of variation within the sample, and maybe all you need is just more data points and more observations in order to make a cleaner, better test. So instead of 10 observations over here, I went ahead and I added 10 more observations over here. And these extra 10 observations were just added using the random function in Excel, and I copy pasted the values over here. So based on this, I ran another data analysis, Anova single factor, and selected all these observations, and the results are given over here. So the results for these observations is like you have 20 observations, the averages and variances are found. you have the sum of squares for between groups and the sum of squares for each of these groups. And here you find out that the F statistic is 5.33, at least based on these extra 20 observations. So in this scenario, the F statistic is actually greater than the critical value of the F statistic. And in this scenario, you can reject the null hypothesis that the means are equal. That means, and you accept the alternate hypothesis that here that the means are unequal. So the averages for DoorDash, Uber Eats, Skip the Dishes, and Foodora are clearly different from each other. And based on eyeballing, you could kind of tell that there are more values closer to 20 for the last two rather than the first two. And then you could narrow down on your question if you want to narrow down on the difference between DoorDash and Skip the Dishes or DoorDash and Foodora. You could go ahead and perform a t-test for these sort of samples. And that will be the next video, in fact. And this is how you use Excel. Go to data analysis, single factor, select the group, and figure out where you want the new worksheet, or you could select a new worksheet and create a new output as well. And if you select new worksheet, a new worksheet will be created in your Excel, and all the output will be given to you. And make sure you understand how to interpret this worksheet. But it's also important to actually know how to compute the F statistic without the use of data analysis. And that would help you double check your answers for certain scenarios. Okay, and that's it for this video.